Okay, what I want to consider at the moment, and this is not in your notes, so it's really playing around with this, is just looking at the idea that the derivative of sine x is cos x. So the idea here, if I derive sine x, and I'm going to use the program here, and I'm going to get it to show me it's the derivative, and it's going to give me the graph of the derivative. Now, again, consider the derivative here. At this point, it's increasing, and it gets to a point where it's 0, decreases to another point where it's 0, and then it starts to increase again. If you have a look, the gradient of this point is 1. So it increases to a point at pi and 2 where it stops and then falls. Now, if you have a look at that curve, which is telling me it's the first derivative of sine of x, that would actually be cos of x. Okay. So that's interesting. That shows me the graph of it. And if I graph cos of x and got it to do that, it should go right over the top of that derivative there. So that shows you that the derivative of cos of x is sine of x is cos of x. So what about if we consider keep cos of x, and there's cos of x again. But what about if we want to look at the derivative of this one here? So let's show its first derivative. Now we've been told that the derivative of cos of x is minus sine of x. Well, let's prove that. Let's show that what sine of x looks like. Well, there's sine of x there. And then if we, instead of taking sine of x, let's take minus sine of x, which means it's basically just flipping it there, and it should come up as a pin curve over the top of the first derivative. It's actually telling me it's the first derivative. It's picking up the first derivative. But there we go. There's minus sine of x is the derivative of cos of x. So you can see the relationships that exist. So there's sine of x. It's being flipped in there minus. So that's where we're able to use the idea. And showing on a graph just, I think, helps to see that idea there. If we need to stop recording.